Guys, I have a question from Moment to solve for you. Here we go. The question is asking, determine the magnitude of the moment of the force F about the x, y and z axis. Solve the problem A using a Cartesian vector approach and B using a scalar approach. Determine the moment of this force F about an axis extending between A and C. Express the results as a Cartesian vector. So let's begin with a scalar approach. So let's see what we can do about that. So here we go. So the first thing is we had to find the magnitude of whatever the things they have given, like not magnitude, actually Cartesian vectors. So if you want to find Cartesian vectors, uh, here we go. First, let's start with the B, because B is the end, right? So we have to find the B. So Cartesian vector of P is gonna be, if you see, it's 4 feet long from x-axis, so I'm gonna put 4 here, and 3 feet long from y-axis, 4i, 3j, 3j, and 2 feet down, so it's gonna be negative 2. This plus, this is minus 2k. So, and now the force is given, which is 4i plus 12j minus 3k lb. And first, if I choose scalar approach to find x moment of x coordinate, I had to use, first I put this is a formula, a general formula about this. So it's going to be, if x is here, we have to put y and fc, then z and fy. So whatever the two values missing, we have to switch around, and then to find the direction, to find whether it is positive or negative, I had to do the right hand rule. So for example, for this one, if you like right hand rule, you have to know that you have to use 3 fingers, and if you keep the one finger in y and other finger in c, the third finger points outward, so it means it's positive. And for the other one, if you put one finger in z axis and other finger in the y axis, right hand rule. So make sure you are using right hand, right? So if you keep your right hand in the z axis and the other finger in the y axis, it's going to face inward, so it's going to be negative. So from this, now I can calculate mx. mx is going to be um, mx is going to be, first of all, what is y here? 3 is our y in the final things we have found. It's 3 is our y, and it's 3y and fc. So this is my f value. I have to multiply by fc. This is minus 3, so I had to multiply this one by minus 3, and then minus z value is minus 2. I had to multiply this one by fy is 12j, so 12 multiply by 12j. So what I get is minus 9 plus 24. So 24 minus 9 is going to be 15 feet 15 feet pounds. So this is my mx. To find the my, I have to use the same approach. This is don't forget, this is scalar approach. Scalar approach. So my, to find the my, I can put if it's y, we have to put x and c. So x f c, then z f x. So to find the direction, I have to use the right hand rule. If I put one finger in x and other finger in the z, is pointing inward, so this is negative. And for this one, if I put one finger in the z axis and other finger in the x axis, it's pointing outward, so it's positive. So now what I'm going to do, I'm going to plug this values. X value is going to be 4 times fz is, here it's -3, so I'm multiplying by -3 plus z value is -2 multiply by fx is 4, so which is going to give me 12 minus 8, so it's going to be 4 feet, 4 4 feet lb, right? That's my final answer. And I'm going to use the same approach for the mz. So in here now I'm going to put if it's c, I have to put y and x, so y fx then x fy. Let's use the right hand rule. If I use the right hand rule, and if I put one of my finger in the y axis and the other one in the x axis, it's facing outward. Oh no, wait. So if I, okay, it's facing downward. Downward means this is negative. This is negative, and for the other one, if I use if I use this x, if I put one finger in the x-axis and the other finger in the y, it's facing upward. Upward mean positive. So minus y, I am going to copy the number, so it's going to be minus 3 times fx is 4 times 4 plus x is equal to 4 and times fy is 12. So it's going to be 48 minus 12. 48 minus 12 is equal to 36. So 36 foot-pounds. So these are my scalar approach for this question. And next question, they're asking determine the magnitude of moments of the force F about xy and cx is solve problem using Cartesian vector approach and using a scalar approach. So I have done with the scalar approach. So let's do with the Cartesian vector approach. So Cartesian vector approach. Vector approach. Uh, the general formula for this kind of question is mx, if the moment x is equal to ux, unit vector of x, and then multiply by b and f. So if they have given the b, we have to simply cross, but not multiply, cross b and f. So it's going to be b cross f. So what we going to do is, first let's list all of them. So usually unit vector of x is going to be 1 0 0 because I is 1 and others are 0. So if it's unit vector of y, it's going to be 0 1 0, and if it's unit vector of z, it's going to be 0 0 1. So it's going to be like that. So instead of u of x, I'm going to put 1 0 0, and b, we already know it's 4 3 minus 2. We have found the b already, so it's 4 3 minus 2, and we know the f is 412 minus 3, so I'm going to use that one here. 4 3 minus 412 minus 3 sorry, 412 minus 3. So now what I have to do it in order to cross that. So let's say this is I, j, k. So I have to cross all of these values. In order to cross that, I have to copy ij again. It's gonna be ij 1043412. So let's cross this. So it's going to be the diagonal like thing. So this is my positive cross. So this is my cross product, and if I cross and multiply, then let's see what happens. So 1 3 times minus 3 is going to be negative 9. Negative 9 plus negative 8 is going to be negative 8 is going to, okay, this is 0 because 0 times negative 2 0 0. So 0, so negative 9 is the only thing remaining in the positive cross. So now I have to cross the other side. It's going to be negative values, like whatever the value you get, we just negative it. So it's going to be like this, from starting from here, here and here. So it's going to be like this is 0 times this is 0, 0 times 0 0, and 1 times 2 negative 2 is negative 2, negative 2 times 12 is negative 24, but this direction is negative direction, therefore negative negative 24 positive 24. The other one is 0 times 4 is 0, 0 times negative 3 is 0, so for positive 24, positive 24 minus 9 is going to be 15, 15 feet foot pounds. So if you check with the scalar approach, we get the same answer. So that's how we got it. So we can use the same thing for my. My is going to be uy unit vector y and b cross f. So it's going to be 0 1 0. Others are going to be same thing, 4 3 minus 2 minus 2 4 12 minus 3, and I have to copy ij again to cross this. So it's 0 1 0 1, and here it's 4 3 4 12. Let's see what happens if we cross. So I have to cross this one first, this one first, this one, and uh, then starting from here, this one and this one. So if I cross this one, 0 times this 0, 1 negative 2 times 1 is negative 1 is going to be positive, is it, wait a minute, this is 4, this is 4. So 1 negative times negative 2 times 4 is negative 8, and this is 0, and this dragon, these are 0, these are 0, and 1 for 1 times 4 is going to be 4, 4 times negative 3 is going to be positive 12. So positive 12 become negative 12 become positive 12. So positive 12 minus 8. So minus 8 from positive direction plus 12 from the negative direction, therefore it's going to be 4 foot pounds. So that's what I have got here too. And let's do mz. Mz is gonna be v sorry, ju z b cross f, and in this case I'm gonna put 1 0 0 1 for z, and 4 3 negative 2, and 4 12 negative 3, and I'm gonna copy ij again here, ij, oh sorry, I have to write it on the top, but it's okay, even if you write, if you understand, it's okay. 0 0 ij 4 3 4 12, right? These are my ij values. Now I'm going to cross it, this one cross, this one cross, these three things cross, and from here this one cross, this one cross, this one cross. So 0 0, this 0, this 0, and 1 times 4 is 4, 4 times 4 is 16, so 16 from the positive direction, and 1 times 3 is 3, 3 times 4 is negative 12, so negative 12, so it's in the negative direction. Therefore, wait a minute, so did they get it right? So 1 times 4, 1 times 4 is 4, 4 times 12 is, or this 48, 48, and this is negative 12, because 1 times 3, 4, 3 times 4 is 12, it's going to be negative 12, others are 0, 0, 0, so this is negative 12, so it's going to give us 36 foot pounds. So this is my vector approach. I have solved this question from vector approach. Let's see what's the question asking again. The scalar approach, we have done this question, and determine the moment of this force F about axis extending between A and C. Express the results as a Cartesian vector. Okay, let's see what we can do here. So first of all, we have to put the formula for this one. So they are saying uh, find the determine the force F about an axis extending between A and C. So extending between the, okay, this is a line right here. So we have to find the moment in this line. So it's going to be MAC. MAC is going to be, so if you, as you know already, if we want to find a moment, we have to multiply its unit vector and force, right? Unit vector, and in this case unit vector and cross product of these things, AB and AB and F. So let's see what happens. So first of all, before this, I had to find C to calculate AC. So C, I had to find that. Let's see. So C is 4 feet in the x-axis, so it's going to be positive 4, and 3 in the y-axis, so it's going to be positive 3, and 0 in the z-axis because it's not going up or down, so it's going to be 0. So 4i plus 3j plus 0k. This is my value, and as you know, a is in the origin, so this 0 0 0, so if you AC is going to be C minus A, so if you deduct 0 0 0 from this number, you are going to still going to get the same number. So AC is going to be 4i plus 3j 0k. So this is my AC. Now to find the unit vector, as you know already, it's going to be just AC over square root of this number, right? So square root of this, like 4 square plus 9, 3 square is going to be 16 plus 9, 25. So I have to divide everything by 25. If I divide, oh, it's square root of 25, 25, square root of 25 is 5. So if I divide everything by 5, let's see. So I'm writing this again, 4 3 j plus 0 k. It's going to be 4 square plus 3 square, 16 plus 9 square root. So it's going to be square root of 25, and 4i plus 3j plus 0k over 5. So if you divide that one 5 by 5, it's going to be 0.8i plus 3 0.6j plus 0k, right? So this is my UAC, and AB is what? AB is B minus A. We have calculated the BA already. If you see the previous solution, we have done it, but let's see. I'm going to write B again. B is going to be what? A is 4, uh, no, X is 4, Y is 3, Z is negative 2. So it's going to be X is 4i plus 3j minus 2k, and AB is going to be same thing, because as we see in the previous one, AC is same thing because it's deducting from 0 0 0. So AB is going to be B minus A. So b minus 0 0 0 is going to be same thing. A is in the origin, that's why. And now since we got all the values here, now let's cross it. If we got all the values, we are ready to go, right? So let's do it. So I'm gonna list from one by one. So first one is UAC. UAC is what? 0 0.8, 0 0.6 and 0. Then I have to copy this again to cross it. 0 0.8, 0 0.6, and in the bottom it's I have to copy AB now. So it's going to be 4 3 minus 2 4 3, and then UAC AB cross F. So F is F, we already know this is 412 minus 3, so I'm going to copy that. 412 minus 3, 412. So now if I cross this, this times, okay, this time, 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 this is my positive direction. So it 2.4 times 3 is gonna be 4.8, 4.2, 7.2, 7.2, negative 7.2, and this one is going to be negative 6 times 2 is going to be 1 point, negative 1.2, 1.2 times 4 is going to be negative 4.8, and this is 0 0 0 0. So we have to, now I'm going to calculate the negative direction. It's going to be 0, this is going to be 0, and this is going to be negative 0.6 times 4 is going to be 2.4, 2.44 times 3 is going to be what, 4.8, 5.2, 7. Negatives, it's negative 7.42, but it's in the negative direction, so it's going to become positive 7.2. Positive 7.2, and I think we have, okay, we have missed this one. 0.8 minus 2 is going to be 1.6, 1.6, negative 1.6 times 12 is going to be 19.2. 19.2, so plus it's negative 19.2, therefore it's going to be plus because it's in the negative direction. So if I add all of them together, I will end up with 14.4 food pounds. 14.4 food pounds. So this is my final answer, but we are not done yet, because the question is asking determine the moment of this force F about an axis extending between A and C and express the results as a Cartesian vector. So in order to express this result, I have to simply multiply this number by UAC. I have to dot this number by UAC. So let's see what happens. So UAC dot what do we have on MAC? This is MAC, right? MAC. So UAC dot MAC is going to give us a Cartesian vector. So if I multiply this number by 0.8 first, let's see what happens. 14.4 times 0.8, it's 11.52 I, and plus 14.4 times 0.6 is going to be 8.64 J, plus it's 0K. So that's the final answer for this question. I hope you guys enjoy this video. See you next time.